Good morning, guys. We're going to talk about the laws of logarithms. So what happens is if I need to add or subtract multiple logarithms together, there's some rules that we need to use. So the first thing that I want to bring to your attention is to do this, your bases have to match, like have to match. So the little numbers down here, the little subscript has to be the same. If they are not the same, you can't do this. We're going to have to figure out another way to solve it. We can't apply these to the problem. So we're probably going to use the top three. The fourth, I don't know if we'll get to. It's more of a common sense one. So let's go through these. The first one says if I have two logarithms, again, bases are the same, that are being are being added together, then we're going to multiply them. So again, adding, if I'm adding them together, we're going to end up multiplying just the m and the n are going to come together, right? Actually, let me change that. Let's go back to this color. Let's do green. And notice how it's just those two. We're going to take just those two numbers and we're going to multiply them together. Okay? The second one states that if I am subtracting, I'm going to divide them. So again, look, here's m and here's n. Notice I just take those two numbers and I do the division. Okay? The third law states that if something is written in front, so this would be written big, this k here is written big. Notice how that k comes up and goes here. It goes to the exponent. Notice how it is, oops, there we go, up here now. Okay, you see where it goes from being written in the front to up in the exponent spot. And the last one, all it's stating is that if I have a log, singular, 1 on the one side of the equal sign, and I have another log, singular, on the other side of the equal sign, they both have the same base, then what it's telling me is that this is equal to this. So that's where this is coming from, okay? That means I can just drop the word log, solve that part, and I can get my answer that way. So let's look at a couple examples. There we go. All right, so the first law, again, adding means multiplying. Okay, so the first one states that I have log base 2 of 5 plus log base 2 of 8. First thing I'm going to look at is my bases are the same. Oops. Okay, so my bases are the same. That means I can go ahead and I can multiply them. So this becomes log base 2 of 5 times 8. Okay, or here. So this becomes log base 2 of 40. And that's it. I simplified it. It's now down to a singular log. If I need you to solve it, we can then use the change of base that we learned before. But for right now, that is fine. I just need you to simplify it down to that part. Try the next one. All right, so again, looking at this, my bases are the same. So I can multiply them together. This is log base 4 of 5 times 2x. So this is log base 4 of 10x. Done. Okay. Law 2 tells me that if I am subtracting, I would divide. Again, we're going to look at my bases. Oops. Let's undo you and go to my highlighter. My bases are the same. This is more of a setup problem. Order matters. In this one, order matters. First one goes on top, second one goes on the bottom. So this is now going to be log base 4, right? And the first number goes on top, second one goes on the bottom. And that's it. It's done. Try the next one. So for this one, again, even though we don't see a base here, right, we understand that's a 10, right, because nothing's there, okay? So this is telling me to go log and then 15 over 3. That can be simplified. So if it can be simplified, you should simplify it and tell me that's just log of 5. Okay? Our first one couldn't be simplified, so I would leave it. But if it can be simplified, you should simplify it. The third law of logarithms is the exponent one. And this one, more often than not, I use in both directions. So right now I'm showing you how to move a number up front to make it an exponent, but sometimes you move the exponent out to help solve things, but we'll see if we get to that. Let's just go in the first direction. So I'm going to take this 6, bring it up, and make it an exponent. That's all I'm going to do. So this changes into log base 7 of x, and that becomes a 6 up there. And that's it. It's simplified. Try the next one. So again, I have 3 log of 6. So we're just going to make this log of 6 and make that to the 3rd power. And that's simplified. Okay? All right, so now we're going to put them all together. So when I'm going to solve a problem, I'm going to use all of those laws. So first thing I would do is I'm going to scan the problem and see if I need to use that 3rd law for anything. So I notice this 2 needs to come up and become an exponent. And the next one, it's fine. So I'm going to do that first. This is going to become log base 3 of x squared plus log base 3 of y. I'm now going to check. My bases are the same, and I'm adding. So that means I want to multiply them. This means this becomes log base 3 of x squared y. Done. Okay? I took it from being more than one logarithm, and I got it down to 1 logarithm. So try this one. Let's do this one together. So again, looking at this problem, this 6 needs to come up here and become an exponent, and then this 2 needs to come up and become an exponent. So this becomes log base 5 of x to the 6th minus log base 5 of 11 squared. Looking at my subscripts, they are the same. So now I can do the subtraction, which tells me to divide. So this is log base 5 x to the 6th over 11 squared. That would work. Or you can tell me that's log base 5 x to the 6th over 121. Either is acceptable, but that's where you would need to be. If you have any questions, join our Google Meet for class. You can email me and I will help you that way. But obviously, if you have questions, please ask. If not, have a good week, guys.